Hello, this is Aloisa with Math Leopard, and today we're going to show how to understand the derivation of spherical coordinates with respect to rectangular coordinates by way of polar and/or cylindrical coordinates. So let's get started. Suppose we have a point P at XYZ located in 3 space. That point P is at a certain magnitude or distance as measured from the origin, which we denote by rho. Now let's project the image of P onto the z-axis, which is done so perpendicularly. We note that the vector P creates an angle phi as measured from the positive z-axis. Using our trigonometric identities and noting that phi is adjacent to the z-axis, with rho being the measure of the hypotenuse, then the z-coordinate of P is at rho cosine phi. Now let's project the image of P down into the xy plane. We know from geometry that alternate interior angles are equal. Hence the angle made with the vector P and a perpendicular to the floor from P is also phi. Noting this point on the floor, we see that it is a distance from the origin that can be measured in 2 space, as on the floor our z-coordinate is 0. Let's call this distance r. Using trigonometry once again, and noting that the side measure of r is opposite angle phi, we have that its magnitude is equals to rho sine phi. Projecting vector r onto the x-axis, we note that it's at an angle theta with respect to the origin in the xy plane. Hence, in polar form, we know that our x-coordinate would be at r cosine theta. Yet for us, the measure of radius r was found to be rho sine phi. Hence, the x-coordinate becomes rho sine phi cosine theta. Now let's project the vector r onto the y-axis. We note that the distance once again can be expressed in polar form with respect to r and theta, as r sine theta. However, the magnitude of r being rho sine phi yields a y-coordinate of rho sine phi sine theta. Hence, any 3-dimensional rectangular coordinate xyz can be expressed via cylindrical coordinates as r cosine theta, comma r sine theta, comma z, which is really polar coordinates with a single perpendicular degree of freedom attached. And finally, in spherical form as rho sine phi cosine theta, comma rho sine phi sine theta, comma rho cosine phi. Thanks for playing, and I'll see you next time.